Alright, let's go. Had to lock the fuck in. Not much later. This. I need related music, not the same. Let's see what's next. New shit. This is the same. Alright, this. Alright, let's go. Sorry, took a while to get started. Had to lock the fuck in. I was having thoughts that I wanted to just chill out, watch some fucking... Too loud. Watch some... Just not a good start to the song. Wanted to just sit down and watch some Breaking Bad. Because it started late because I was playing... Well, I was playing video games with buddies. And then I had to eat. And I was watching Breaking Bad while I was eating. Then I got caught up. Had to finish that episode. And then most of the next episode. Then I had to fill up my water. And I was just like, nah, fuck this. I need to change my life. Need to get a better job. Need to do stuff that I actually care about. Every day that I spend just sitting here and just sitting down and watching fucking Breaking Bad without locking in, getting this done, is a day that I'm not putting enough knowledge in my head to get me to where I need to be, which is making my game and making other games and improving VR technology. VR tech specifically for my game, learning game development and getting better at it for my game, learning programming to both of those ends for my game. And to do that, I can't just do this shit for 3 hours a day. It'll take me fucking 40 years. So, I need to get a job where I'm actually using C++ and get a job where I'm paid to work on other people's games and to make other games and eventually make them how I want them while using the same state-of-the-art, one, information in my brain in my free time to make my game, but two, contributing to the technology so that I can use it and either implement it or take it or copy it or make it or whatever and bring it to mine. We get some new, technology to simulate scent in the game. So now you can have a headset and instead of having to run tubes from cartridges with scents that mix together to make the right scent, to put scent in the game, instead we're actually simulating it in your mind. We're turning on the specific little regions of the brain and we're sending the right signals and converting them the right way to make you think that you're smelling freshly baked bread in the fantasy tavern that you're in. Or I guess a tavern doesn't make bread, do they? Let's say they do. The bread-making tavern people come about during lunchtime, and then dinner it turns into a real drinking tavern. That. Simulating that in your mind. That is what I want in my game. I have to make it because nobody's making it. So, let's go. Okay. Tomorrow will be the same thing as a weekend. I'm going to do 3 days. Tomorrow's Friday, 4th of July. I have the days off. But when I wake up, I'm going to treat it like a work day. I have to go and watch my boss's dog. I got promoted, so it's now my boss, not my boss's boss. Watch his dog in the afternoons. I got some shit to do. But I can go over there and I'll lock in enough in the rest of the day, and then I'll watch Breaking Bad over there, because it's hard for me. I hate sitting down at someone else's house with my shitty laptop, but I can still do cool stuff, so maybe I could do it. I just fall asleep. I'll try. But regardless, I'm going to wake up tomorrow, alarm, go. Wake up, hour and a half of whatever, watch Breaking Bad while I'm brushing my teeth and stuff, and then, boom, alarm goes off. This. 30 minutes, rest. Breaking Bad. Alarm goes off. This. Repeat until, 6 o'clock. He leaves at noon, so he's already fed the dogs in the morning, so I just have to come for the afternoon. And cool, they'll have been taken out in the morning too, so I just need to do that. So I'll come over in the afternoon, and then I'll just stay there, and it's fine, because I got to spend the night to take care of them in the morning, and then I can come back over here. So, just trying to work this out in my head. Sorry, I shouldn't even be recording it, but it's fine, fuck it, don't care. Okay. And then Saturday, I wake up, take the dogs out, feed them up, come over here, learn, alarm, 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 from 9, 10 till 6, and then I go back over there. and then whatever. Either keep being productive or already have been not productive enough, but have been productive enough that I won't hate myself for it, maybe, and still try and do pieces over there as much as I can. And then Saturday or Sunday, wake up, feed the dogs and shit, come back over here, learn, same thing. So tomorrow, alarms till dog time. Saturday, alarms till dog time. Sunday, yeah, it's basically the same day each time. Wake up, but instead of waking up here, alarms straight away, no dogs. But then Saturday, it's wake up dogs, come over here. And each day I go over there for the afternoon. I think Monday too, maybe. Okay. Let's go. So, pass by address. I'm going to assume this means passing a pointer to something. I've already experimented a little bit with some of this. Like if we have, for example, int x is 5, okay? Let's make it more fun. Let's just say const expression int x. Could I? Why not, huh? We receive it. I'm curious, is there a type of a pointer that receives a const expression int? It seems like the const expression isn't mandatory. No, I guess it guaranteed is compile time, but it should still maybe treat it as a pointer. Let's find out. So I'm going to make a pointer to a const int. Oops, sorry. Int pointer, and we'll just say xp, sure. And it is the address of x. Is it happy? Cool. It doesn't care about the expression part. It only cares that x is const, which is good. Oh, fuck. I've been using the wrong voice thing, so you've probably missed most of what I've said, and I've looked like more of a psycho than I already look. Okay. Let's get the fan on. I need to... Okay. This is not working. I rotate this guy around. Okay. So... fan is on. I'm gonna assume... Oh, wait. No, I already did assume. This already works. I already know this. Okay, cool. So, I was just making a pointer to a constant real quick. And if I wanted the pointer to be unreseatable, we could just make it const2 like this. Like, hey, not only can we not change this through this pointer, even if this was just a regular int, we still couldn't change it because it's treating the pointee, whatever it's pointing at, it's treating it as const, so we can't change it through it. But now the pointer actually can't be reseated either. So, we have... this int x whatever, and it's got this value of 4. Okay, we're gonna get iostream because I need to print some shit. Okay, and we're gonna have a function, and it's gonna be called, sure, fuck it, we'll just do little generic shit. Void update value at, okay, and we're gonna do a pointer to an int, and we're just gonna say value, or at, sure. And we're gonna update the value at. So we're gonna say, excuse me, at is now 5. Excuse me. We're going to output what x is initially. Hello? Sure. And then we're going to call update value at, and we're going to pass it the reference to x. Or sorry, x's address. And then final x. I see that there's only one issue here, and it's that we're missing a semicolon, so it's fine. Yeah, and it's already saying it. Cool. Cool. So, pass address to function to update value at to update. So, we're getting this value, the temporary value of this expression here, the value of x's address. And we are copying that value into so it's a temporary value, just like saying x plus plus. Sure, we're incrementing x. So x plus 1, that value is somewhere, and we can pass it to something else. In this case, we're saying x, this object, its address. Well, that's not stored anywhere. We're talking about an R value now, I'm pretty sure. This address, we are passing somewhere. In this case, we are copying the value to another temporary value. So there's a temporary value here that initially is holding x's address, because it has to be somewhere. We can't say that it's nowhere. It has to be in a temporary variable, or at least temporary object, because it's not a variable because it's not named. So we've got this temporary, this r value in this case, this piece of memory that's holding a value that is going to be lost the second we don't use it. We have it in this case, if we just had and x, then nothing happens. This is just the return value of the address, nothing happens. So return value, but it's not that nothing is happening to it. We're actually passing it by value to an integer pointer. So this is a pointer. The address of returns a pointer to the object we're talking about. So object, address, temporary object holding the value, copies to another temporary object. So the address is copied over to another integer pointer, but I can dereference that pointer. The point is that I have the object and one pointer to it, this return value, and I'm copying that value somewhere else. They're both pointing to the same location. I can dereference this one to change this. I can dereference this one to change this. So if I copy a reference by value, or if I pass a reference itself, ignore the thought. Okay, so I can dereference this location. It's just like telling someone the instructions. Hey, the bank is over there. Here are the coordinates of the bank. Let me copy them into your notebook. I have a little temporary notebook of the bank's address. Now you do. You can use your instructions to go to the bank just like I can. 2 copies of the same address, 2 separate variables. In this case, a local one. In this case, an R value unnamed temporary object one. And they both look at the bank. So now, 4-5. Cool. I think that's what we mean by passing by address. We are passing the address of something to initialize a parameter to a something. So now those two are linked together. There's a pointer waiting to look for something to be initialized with some value somewhere, via copy initialization. So narrowing conversions would be detected, but it doesn't matter in this case. Unless you pass too big of an address, if that's even a thing. And we copy it to give it the instruction, and boom, now we can change that shit just like we could via reference. The reference version would be void update or update value with or update value via ref. Sure, that's fine. And we'll say a reference to an integer. Ref. And now ref is 40. And now update value via ref. And we're passing. Could I make it temporary? I guess not, huh? Let's see. I don't think I can just do that. I think I have to say... Well, let's try it the regular way. So we'll say, okay, well now we have an int reference called xr, x reference, and it's initialized with x so that it is bound to x, and we now are passing this guy. It doesn't have, it's saying right now two errors. 1, no arguments. 2, no semicolon. So if it was whatever. All right, now we're gonna pass it xr, and boom. And then address or post address update x, post ref update x. Cool. So we have x. That's it. We have passed the address somewhere else so that that somewhere else can look where x is and update the value where x is, which updates x because it's not a dangling pointer. In this case, it's probably a good idea to say only do this if at. That way we know, check if pointer is valid. Or, well, we could just say validate pointer, or well, is pointer valid, or if pointer is valid. Sure, if, yeah. And I could say if at is valid, but that's fine. Update referent through, excuse me, bound reference. I excuse myself for yawning. Initial value of x, update it via a reference, because we have to create a reference and pass the reference, or sorry, in this case, pass the address, update it via a pointer to that address. And we don't need to do anything specific. I don't need a reference to a thing. I just copy the value. So like if I did a reference to a pointer, then it doesn't make any difference. And in that case, this is temporary. It's probably going to say expected L value. Yeah, exactly. So I could make a const. Yeah, but this is just crazy. I could make a const L, or an L value reference to const, and then initialize it with the address of x, which is a temporary value. And then that will prolong that temporary value in lifetime. And then I can make a pointer to it, and then I can pass a reference to that pointer. Or I could just pass. Yeah, I have to have a reference, and I can have a pointer to the reference. I wouldn't want. Yeah, and then I would just pass the pointer value anyway. Yeah, it doesn't make any difference, but they're just different ways of approaching the same thing. Seems like pointers can sometimes be easier just by being more concise. For example, if we just said int x is 5, and we said int, and then we could just say dereference the address of x is now 6. We've now updated x through getting a temporary pointer and updating it. And then I can output it. But if we do a reference, maybe we could. Can we do I don't think so. I don't think I can create a temporary object. Oh. But we can do a unit. We can create a standard uniform int distribution and initialize it and call the Mersenne twister in one line. Yeah, return that guy there. So I need an expression. So would that work? An int reference. Does it? It's not an object. So does it need an identifier? X. Can I have a temporary one? Maybe not. Yeah, I guess your reference has to be named, huh? Damn. Because that could be cool. I was thinking we could have a reference like this. And then, but no, because I can't do double assignment, I think. In this case, we're using or list initialization here. Assignment during definition. But then I was hoping I could do something like, hey, here's a reference to this, and then equals 6. With this to update it, but I can't. You have to create the reference separately, which means point same as my initial point, that we could have int x is 5, and then dereference a temporary pointer to x to be 56. Fuck it. I mistyped, but it's fine. Or int x, and then int reference to x, and then xr is 6. Extra steps. Takes 2 lines compared to takes 1 line. Update via pointer. Update via reference. Cool. Okay. This is a full-on banger. I trust it. I trust it. The voice is going to be good. Is it Hanathon? 4 years ago. No, different. That's pretty good. This is really good harmony. It's a guy and a girl. Holy shit. That's really good. I don't know what playlist that is, but it is what it is. Alright. Can we trying to click somewhere, but fuck it. Two different ways to pass an argument. Yeah, so we can pass a value and have to make a temporary L value, or well, an R value that holds that value of the object that we're using, the value we're passing, and we copy that to another, well, I guess to a parameter. Parameter, object. Both of these are L values. R value gets created to hold this value so that it can then be copied to the parameter. Object, R value, parameter. Object, temporary R value, parameter. Both of these are L values. The object and the L value are, the object and the parameter are L values. Temporary is an R value. We can pass by value, we can pass by reference. Where? Excuse me. Object. Reference to the object. It seems like a reference is a shortcut pointer kind of thing. So the reference in the as the parameter reference is kind of a pointer to something. So I'm creating basically like a pointer to X, and then I'm basically giving that over. It feels like I'm copying it by value and then bringing it over, but it's like the reference is already a dereferenced pointer. That's why I can just assign it value. It just references that piece of memory. It's bound to it. It's looking at it like it's using a scrying spell or something. So the point there is object. Create a reference to the object. I don't know if the same stuff is happening under the hood, where it's copying the pointer and then bringing it over, or if it's actually just initializing it some other way. It seems like that's it. It seems like it's the same thing, it's just it's maybe more convenient syntax because we can say, hey, parameter equals 8. That updates the reference to the guy, which is the guy, because they're all looking at the same place in memory. They're all looking here, they're just calling it different ways. He calls it a pointer to here. He calls it a reference that's bound to here. The parameter sees, oh, it's the value copied from here, but it's not actually here, so it can't change it, but these two can because they're looking at it. The pointer or the reference and the pointer are both actually looking at the place in memory and can change it. Okay, I have a new mouse pad coming, by the way, too, because I don't know if it's the Osu game. If it is, I'm testing two things. If the mouse pad fixes it, good. If it doesn't, new mouse. If the new mouse doesn't fix it, okay. Then it's the computer or it's Osu. When I play Osu, sometimes, I was playing earlier, the cursor will just skip around. It'll just be like, good, and then it'll stop for a sec, or it'll like jolt in the way that I'm not telling it to go. Excuse me, like a shitty quality mouse, because if you move it quick, they can't track, they can't do this. Because I'm doing that, like, that's a lot of motion. Okay, I don't know what happened to this page. I have no idea. Is it ad block? No, it's not my ad block. Bro. Oh my god, what happened? No porn. Okay, thank god. How did we get to 2.4? How did we even get there? Oh, because it's fucking right there. Okay. I guess just don't click the corner. Or in the page either. Just don't click, I guess. Can I open this in a new window to see if it's still fucked up? It is. What about another page? I swear no other page was like this. All the pages are like this. What changed on my end? Don't need that. What if we turn that? Oh my god! Nope. It's not dark reader. I don't have anything. I mean... Okay, just don't click the page. We cover 2 different ways, value and reference. Cool. Pass by value and pass by reference. Cool. We're probably copying this guy in, and then we can do, oh yeah, const reference. Well, I know how to do this. We just say, hey, the parameter is a const reference, and then yeah, and then we create a const reference to it. Or, oh yeah, true. Fuck, that's true. I forgot. It can actually be that convenient. We pass an object to initialize a reference, and the reference gets the address and I guess dereferences it automatically, so we can just assign the reference without having to dereference it and assign something like that. So I don't have to create a standalone reference variable or object. Variable? But it's not an object? I don't know what we even call it. So, mistake on my end. I'm not super fully fluent in uh-oh, that's not it. I can pass the object itself to initialize the reference. I don't have to create a reference and then wonder how the fuck is the reference being. It's a reference to an object? Bro, what? That made it look like it was from 1 to 3 steps, but it's really from a reference to an object to a reference to a reference to an object. Just like oh, duh, it's fucking, we can't assign it. It's const. What is happening here? Motherfucker. It's a, I keep doing the wrong, just the wrong key press. 0? A warning? But chill the fuck out. Pass the address. Come on. Bro, no. How about this? You happy? Okay. It's 5. Oh, well. Well, I can only read it here, but can't change it because it's not modifiable. Yep. Cool. Okay, I can pass it straight to a function's parameter. I don't have to create a fucking pointer and then pass that pointer. I just return the, I just call with the pointer. I call with the address of, which is a pointer to temporary. Okay. Yep. The function parameter is a reference that binds to string. It's a reference to a string, which means that it's a reference that can only bind to a string, and it cannot be used to modify the value. I have hello world, and I call print by value, and I copy expensively the value of hello world. I think in this case we have a parameter and we have an object, and I'm taking the value and I'm expensively copying it over. If it needed to be converted, it would be copying it into a temporary for the conversion that matches this type. So we convert from this type to this type, and then we copy again, which is double expensive, assuming that the type it gets converted to is still expensive. Yep. Yep. The reference parameter is bound to the actual argument, the object we're trying to pass. I was wondering if I could bind a reference to that R value address of to get the actual address and read the address out, which we can't do yet. But it would have an issue because we would be converting a pointer to an address. It would see, hey, your return value is a pointer. You're trying to bind a reference. It would just say... Wait, that's fine. I don't know what I'm talking about. Alright. The reference parameter is actually bound to the argument. Yes. No copy. And because it's const, even if our referent is not const, we still can't change it. Instead of here, where we're going to pass the address of string. Yep, there it is. Yep. The temporary pointer. Yep. String. Copy string. Pass reference to string. Or pass string to initialize a reference. Pass address to string to initialize a pointer. Value. 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 But it's through copied value, reference binding, pointer to, address of. Oh fuck, is it July already? Oh, God. It's already been April, May, June. I got 3 months left until I have to start really making shit. Yeah, because we're only going to be reading it like that, so we may as well make it const so that we can't fuck with it. Yep. Yeah, the address of. Yep. Yep. We could also pass an existing pointer, sure. We create another one, we create a pointer to it, and then we just pass, boom. Yeah. It's just whether we want an actual existing variable or a temporary object to hold it. An R value or an L value. So when we pass the address, when we're passing the address using operator and, so the address of operator, say it's passed by address. When we have a pointer variable, and we pass it, we say it's passed by address, and the pointer is passed by value. Yes, makes sense because we have. Well, yeah, because we copied the value of the pointer to another. Well, hold on. Yeah. Yeah, the variable is still being passed by address. It's just that the actual address itself is being copied over. Sure, the pointers are being passed by value. Pass by address does not make a copy of the object being pointed to. No shit. Because everything just has a value. And they can look and there's one thing there. That's it. If we make standard string hello world and we print by address and we send it that, we're sending, hey, you, look over there, hello world, update it, or read it, or whatever. I'm thinking there might be no room for conversion, because with reference, hmm. Reference is cheaper than value, unless we're talking about fundamental shit. For pointers, I have a pointer to an object, and I pass it to initialize another pointer. The pointer types have to match. Maybe there isn't any room for type conversion. If we pass a standard string by address, yeah, we're just copying the pointer to it. Yep. Yeah, it's just copying an int basically. Fucking duh. It gets the object and it can address it. Yeah, or it can access it. Yeah, sure. You can dereference it and change it. Yep. Yep. So we either need a non-modifiable guy from the get-go, which will force us to use a non-modifiable, a const pointer, or pointer to const, or we just make the pointer const anyway. Pass the address to initialize the pointer with that pointer return value, the temporary R value of address of X. Changes the value at that place to 6 from 5, 5, 6. Tyler 1 giant. Need more music. Alright. Jesus Christ. Yes. Oh, here we go. We're about to get a const pointer to const. Yeah, I mean, if we call a function and pass it a pointer to something we have that exists, But in the function, I make it a pointer, a const pointer. Not a pointer to const, but a const pointer. It could be a const pointer to const. But the point is, it's a const pointer. Then we're probably already still wanting to pass the value and then dereference that, or pass the point, or pass a pointer and dereference the pointer to change our values. The shit we're passing. Change the value of the argument. The pointer one. Or the one with a pointer to it. Or yeah, the pointer argument, because the argument is a pointer. Like, what are the odds we're gonna reseat the fucking pointer? We say, hey, look at this. But then you start looking at something else. Hello? Const keyword used to differentiate a pointer to const from a pointer to non-const is significant. Yeah. And the point is, by using non-const pointers, every time we see const, we think, oh shit, this is a non-modifiable value, or at least a value that's being treated as non-modifiable. Oh fuck, that's why I'm getting that value must be modifiable error. It's because I need to put I need to remove const here. But if we have all these other const pointers, then we see all these fucking consts in the damn parameters. And are we looking at a bunch of unchangeable values, or are we looking at a bunch of unchangeable pointers, which don't really matter? Yeah. So we're saying that the const used to differentiate the type of value the pointer's pointing to, or how the pointer's treating it, excuse me, that we can manipulate or not through the pointer, is important. Excuse me. Excuse me, the one to make a pointer const, not so important. Because if we pass a pointer, we probably want to fucking use that pointer. That address that it's already been initialized with. So if we use non-const ones, then all consts we see should be this. Sorry, should be this. The type one. The the pointer to const. Consts. So if we see const, it's important. Oh, that's a non-modifiable value. Instead of being, oh, that's a non-modifiable value, or maybe, it's just a non-modifiable pointer. Fuck. So if you're glancing over a function, you might think you have the answer to something when in reality, nope. Maybe it makes things more muddy. Mm-hmm. Ow. For example, we have a pointer to a const character. We have a pointer to a character that's modifiable. And we have an integer count, an integer variable. Then we have a pointer to a const. Hold on. Oh, yeah, that's weird. It already fucked me up. Jesus. A pointer to a const character and it's const. I don't like this. I like it's pointer to a const character. But now it's a const pointer to a const character. And then, oh my god, we did it again for destination. And then a const pointer to a modifiable value. So you have to look and be like, hey, is that a const as in a const character? Pointer to const? Or is that a const as in const dest? Const pointer to non-const. Alright. Yeah, we might see character pointer, or well, pointer to character, constant destination. So a constant pointer to a character might look like a pointer to a const character. Yep, I'm on the sea of spurious. Yeah, I don't know about that being the right word. Spurious claims. I guess just unneeded, unwanted, too much, too crazy. I read this an unseatable pointer to a const character and an unseatable pointer to a character. That's a pointer to a non-const that can be modified. Yep. Prefer pointer to const over pointer to non-const so that we don't fuck with the values when possible. But also prefer not to use the const pointer part. Okay. Unless there's a lot of pointer assigning, or when would I even want a pointer to not be reseatable? Like, maybe there's some that I want to reseat and the names are similar. Not sure yet. And I guess a pointer can't be compile time. Well, didn't we do some crazy const shit for references for static variables? Oh, like a reference to a... I'm not sure. Uh-oh. Integer 5. Pass address of this guy. Pointer, my pointer. Print my pointer. Oh. That's null, buddy. Oh no. Why are you doing that? Yeah. That's 5. Pointer to this object. Address of this object. Pointer. Dereferencing it to get 5. Print it. 0. That's null in the context of a pointer. Null pointer dereference. Oh no. Yeah, let's make sure if pointer. Boom. In this case, it doesn't do shit. Well, yeah, that makes sense. Test if it's null. Boom. Instead of, hey, are you good? Hey, are you still good? We just say, hey, are you null? Yeah, if it's null, return. Or output stuff and return. Or standard abort. Or, oh, standard exit and call cleanup shit. Standard at exit. And then standard at exit. Or standard exit. Boom. And then logic. Instead of, is it valid? If not, is it this? Oh, is it this? Oh, this? Just check if it's not. Is valid? Is input not valid? That's what we do for input. We extract input. Are you not valid? Oh, you're not. How not valid are you? Is it EOF or is it just a shitty input? Then we clear the extra characters. We don't just clear the character straight up. Check for fuck ups first. Okay. Makes sense. Oh, if it shouldn't be, we can assert, yo, motherfucker, assert valid. Oh, meaning in addition? Uh, oh, meaning, what would be the point? Isn't it instead of returning early? Oh, but maybe you want to do some shit and then, not sure. It seems like aborting could make sense. Hey, assert that it's valid. Optionally, oh, meaning both because we have an assert for debug stuff, and then in runtime we have the mess up part. It's like, oh, the assert isn't included, so this. That way we don't just have an assert. So it's not instead, it's also. It, okay, it did get better. Prefer pass by const reference. Well, yeah, because the reference has to be bound to an object. I mean, unless it's dangling. So instead of it being valid, dangling, or null, it's only valid or dangling, and it shouldn't be dangling, so it should just be valid. Oh, gotcha. We can't. Well, I could have a reference to an R value and pass the address of that reference, but that's just extra. So the point is that we can pass R values or we can pass objects. Well, really, I mean, yeah, exactly. I could pass the return value, or I could pass an L value. Yeah, true. We could just pass the object itself, not the address. Yep. True. Yeah, because we have to dereference it and we have to get the address of it. Pass by reference when you can, pass by address when you must. Okay. More pass by address. Oh, not too much, but just a little bit extra. Okay. Optional arguments, meaning default? Yeah. Oh, so it defaults maybe to no pointer? Why would we want that? I'm not sure yet. Whoops. Oh, but maybe the target by default, if the pointer in the function is target, maybe if I don't pass it, then it's invalid. So we could say, hey, if it's a null pointer, then boom. But otherwise, we're explicitly saying that it is a target. So yeah, you could have that and then call it every second, and then it would update your UI on screen to see if your jet has a current target in front of it or not. Getting tired. I'm gonna do push-ups real quick. Excuse me. Two full ones. Both arms. I'll try. Or, no, let's do increase the negatives. Negatives might be better. So, I'll do 5 each. That's hard. 4. Five. 2 more. Okay. I'm getting stronger. Yep. So, if it's valid, cool. Yeah, exactly. That's what I was thinking. Oh, if we're doing address stuff, then sure. I mean, could go either way. Gotcha. But this is happening regardless. Wait, what? Oh, wait, we can't have a const expression one. Yeah, I forgot we can only have const. Maybe it's because the definitions for standard strings aren't known at compile time. Or just somehow aren't able to be executed at compile time. I'm not really sure. Maybe it's just like standard character output, the way of initializing a standard string or storing it in memory, instantiating it. Or we could just say goblin, sure. In this case, we could do this, but then we could call print target. Boom. So at first, target is goblin, and then we could say whatever. It's not set. We could say what is this? Oh, Hunter ending. Elfins John. The thumbnail. All right. Wait, no, goddamn. I clicked. The thing here is that we could say this if not target or target. Well, hold on. I don't know if I want to have this as an if else or if the target is not valid, short circuit. But if it's false, hold on. Yeah, if that's true, then it should short circuit. Because if not target, it's null pointer. We stop and we do this. We say, okay, it's true. Because or statements only need one true. We don't need to see if everything's true. Just like, excuse me, logical ands stop and short circuit. Just like if we do, if the first operand is false. So if this is true and it's null pointer, okay, we do this. If this isn't true, then it's valid. But I don't want to put this if we don't have a target. If it's valid and it's this, then the target. Hello? Oh, we got to dereference it. Or yeah, this is fine. So we could go either way. It's already null pointer, or we're initializing it with null pointer. It's fine. These are both fine. Oh well, I can't really change it, but sure, I could dereference it. So sure. And not needed, but oops. Boom. So we could do it either way. Pass in nothing, still no current target. But maybe I want to differentiate it. So we could say maybe we would want this, else if so target's valid, but it's empty. And we can put whatever. That means target existed at some point and it was lost. Target lost.
or previous target lost, no current target. But then here we'd say no current target, or say never had target, or first target not yet acquired. And we could do print target, sure, with nothing. Print target with still no pointer. We could do print target with, I could say target is this now, and say target, or we could say nothing. So never had a target, never had a target. No, let's do never had a target, never had a target, goblin, and then target lost. Nope, target is goblin, lost target. That way we have different options here. So if we call it at first, oh fuck, we don't have one yet. It hasn't even been chosen, so we use the default value. Oh, same thing. Oh, later on, we actually did get a target, but then later on, well, I can't just remove this in the code. I have to change target to invalidate it. I can't just remove the argument in a game to make the logic happen, I don't think. I guess I could. We could pass a boolean if it's the first call, then we use the default argument instead, and then only call that once per mission, and then set it, and then from then on, if it's not the first, then we pass it something different. And I would be evaluating the boolean before I even call the function, actually, not just evaluating it in the boolean. Okay. One of the more common uses for pass by address is to allow a function to accept an optional argument. That way I can pass it an object and have it not be known. Because if I call this and pass by reference, I would pass the object, but the object exists, so it exists. But I could just call it without the object and we'd be cool. In this case. It's one parameter, it's passed by address and defaults to no pointer. Cool. We can call it with nothing, or we can call it with the pointer to the object. or we could just have an overload. I should have thought of that. We have an overload with no arguments, and then we have an overload with a pointer, and we say, hey, we print the pointer, or hey, we do this, and we just have it specifically like that. And I mean, what that would look like is just. Oh wait, I guess we'd want to return. Sure. Instead of else, I could just do the thing. Wait, is it cleaner? If this, do that. Or if this, it's already going to be doing this. Oops. It's this one, not the other one that had an issue. That's funny. I just passed the object, not the reference to it. Yeah, we can do overloads to do the same result. Yeah. This isn't a great example. We're passing by value, motherfucker. Well, I mean, sure, we can pass by value. It's cheap. Okay, I get it. But, I mean, if you're going to do the examples, you may as well at least still do the same a pointer. But, alright, fine. Makes sense for me because I was doing a target. Not an ID, not a fundamental value that's cheap to copy. Oh, this is good. Oh. True. Changing what a pointer parameter points at. The address is copied from the argument into the pointer parameter. Cool. Easy memory address copy. Now, we have an integer variable. We have a pointer to it. We are outputting that the pointer is non-null or null. In this case, should be non-null. Nullify pointer if we nullify the pointer, okay, what is nullify? Nullify may be unused. Passing the pointer and setting the pointer. The problem here is that this ain't a reference pointer, yo. We can't assign this pointer, our local one, here. Here. No. It's guy, pointer to guy, copy value to this guy, change this guy, distinct from this guy. If this is a pointer reference, then we have a reference to a pointer that points to this guy. But we don't. Non-null, non-null. Bum, bum. Yeah, exactly. Yeah. I tried this yesterday. I think I thrive in a structured learning environment. Cause I'm a tard, bro. That's how it works. A rigid environment, but let me wear headphones or something just to learn, just to listen to some music, keep me locked in because I'm fucking tired. I had to cook my own fucking Korean barbecue. Come on. 32 bucks. That's like a ninth of my groceries gone. One meal. A shit meal, too. Not even good. Oh, meaning that the pointer is still pointing at X. It's not invalid now. It's not null. Yeah. 1 and 2 received a copy and we changed the copy, bro. Yeah. I don't even want to look at it yet. It's funny enough. And const. We hold on. We don't want to fuck with the value, but we do want to change the pointer. So a const int pointer, sure, especially when we want to reseat the pointer. Maybe we want to not fuck with the value if we're reseating it. Sure. Pointer isn't a keyword. How to do that. That song is so good. Oh, and we want a reference to the pointer, yes. And we only want to do that if it's valid. We don't want to redundantly change it if it's already there. Because the cost of evaluating whether it's valid or not might be less expensive than making it invalid already. Is it valid? Well, I guess we say it's a null. Non-null. Null. Well, I guess we can say this is probably a better way. Oops. Don't repeat yourself. And we're passing XP, the pointer. Same. And then we'll just do it here. I mean, I'm repeating myself, so I can have a function that returns whether it's valid or not. So, do I want to pass the pointer itself and then pass the pointer itself? I guess so. A const int, a pointer to a constant, a reference to a pointer to a constant. Oh, well, I guess we'd say, or rather, make null. Oh, I guess nullify pointer makes more sense, huh? Uh-oh, what the fuck happened? Oh, whoops. Oh yeah, because I just copy and pasted. Uh-oh. Oh, wait, hold on. Wait, these are where we're having issues? Why? This is XP. I'm passing a reference of the pointer, huh? Yeah, it's having issues. Okay, hold on. Hold the fuck on. I gotta finish this. What is happening here? Check pointer validity. Hold on. These both take references. What is this? Oh, fuck. Shift backslash? No. Yes. Shift backslash. Oh, because the reference has to match the type. God damn. Oh, wait. Yeah. Because it's expecting... Oh, wait. So this can't be a oh, because it's a reference to. Const reference? Fuck, I don't remember. Well, the reference can't be changed. Isn't that the same? So if we make this a guy, then we're happy. Okay. And the reason is because the reference, a reference of something, of some type, has to match the reference of the referent. And the problem was that the reference in this case is a reference to a pointer to a constant, but this guy is a pointer to an int. Which, a const pointer, like if this was just this guy here, then we're cool. But the problem is when we make it a reference. Oh, wait, hold on. We're cool. Never fucking mind. Oh, wait, here we go. We can copy his value, but if we're gonna actually fuck around with him. Yeah, but does that make sense? A const. A reference to const, huh? Okay. It's interesting. Alright, well now we see, hey, variable. Oh, this voice. Who is this voice? Who's the singer? This is a nice voice. Very good. Annabelle? Sheesh. Go get some fucking merch from these guys. Oh, fuck yeah. Go get it. Order it. $30. A whole thing. I don't know how the fuck you're gonna play it, but play it. Cool, yes. Oh, well, yeah, same shit here. Same shit as what I was doing, yo. Hey, don't copy my ass. Hey. Yeah, so we've got a variable, a pointer to this object, this variable. Check its validity by passing the reference to see, is this pointer valid? I guess it doesn't really matter. We don't really have to do that because the value is the same, so we just care about where the pointer is pointing. So I think this is probably the best way of doing it. This doesn't need to be a reference. We're just copying the value. So, okay. And that's it for the learning part. So now we're gonna do fuck it. Alright, that's it for now. I did Control Shift S again, thinking that this was my own code. I am slump dogged. I'm just going to sleep to catch up on my sleep. I did my shit yesterday, right? Didn't I? I gotta just catch up on it and then wake up and then lock it in. Yeah, I did. It was 2.5 yesterday. I gotta fix the sleep. I'm too slumped right now. I started too late. It's fucking bad. My productivity is just going down. Sure, I could ego it. I just need to do better. That's it. So, alright. That's it. Different night.